I would request 1 minute. Yeah, Yogan to please start the presentation.
Yeah. Can anyone hear me?
Yes, go
Yes.
ahead, please.
Yeah. Okay. So I'll give update on the test side of it. Basically, I classified into three areas that what Tessolve is looking at based on the trends in the test side. So I'll talk about the hardware, automation flow for test, and SLT. And the last one is more of an update to the industry people that the labs that we do. If you look at the hardware aspect of it, which is the key thing, which is going to decide the device is going to meet the specification that it has been designed for. And if you look at the packaging aspect of it, the pitch of the device is going less than 0.5 mm, in some cases 0.3 mm. And those are of like thousands of pin counts. And to achieve the cost of test, we need to make hardware which can capable of testing multiple devices at the same time. We call it as parallel testing, which can go like 8, 16, or 32. So designing such a solution for both the final test and the probe solution is very, what you can say, it has to pass through a lot of limitations that the AT will produce. In other words, the device test requirement for a given ATE configuration may not directly match. That requires, developing some solutions on the hardware of the AT board, which you call it as a load board, and that has to be done considering the real estate available. If required, you need to go to a mezzanine floor kind of concept where piggyback board has to be put in. Designing such hardware also kept need to be mind that you can design, but can it be eventually manufactured? Looking at the testability for the volume requirement, there are minimum thickness you need to maintain, and the number of layers could exceed 40 layers. And looking at the aspect ratio of the pitch, there you may be limited with a couple of vendors who could redo a fab. So designing a solution based on the requirement, how you can eventually materialize the design into a hardware that can be manufactured is a key thing. That requires customization of mechanical requirement. For example, there may be a stiffener standard available, but you may need to customize, which requires deep understanding of the hardware of a particular ATE. And the component library is one of the key thing. If you make some mistake and the hardware, you know, basically goes to dustbin, and this being so expensive, not only expensive, but that cycle time is also very high to reproduce. So what Tesla has done is, we have an in-house team who can help you both, developing the library component and the mechanical team to look at the challenges and customize some of these solution for stiffener. And also, when you develop a schematic such complex one, you may include some circuits that helps to address the DUT requirement. And we have successfully evaluated, some of the complex hardware, both ATE and system level hardwares through a AI-enabled schematic inspection tool, which can take the BOM content of your schematic and look at for the components recommendation from the vendor and find out if there are any deviations from simple one to even circuit level kind of thing. And we also have, if you design a multi-site schematic for a solution, we inspect the golden site for one site. And how does this site matches with the other 8 sites or 32 sites you develop? And if there are, of course, based on the configuration, there may be some changes or non-similarities. And we want to know what those non-similarities and if it is an error, then we want to address it. So some of the automation we have done on that area too, which improves the success of bringing the board in the very first spin. On the test side, the automation of it, if you have a design team which producing a large device, and the DFT strategy has to be kept in place so that eventually when you put a DFT strategy, whether it was able to fit into the AT's memory requirement and the power budget that the AT power supply can offer, accordingly it need to be done. So having an in-house DFT team at Tessolve is a great asset, and they can work with the AT folks or the test team to look at the configuration requirement and strategize the DFT. And we also have the in-house tools which can convert the design files like vehicle EVCD or style file into the AT format. And we also have the suite of tools, which is we call it as test architect tool, which standardize the AT spec and other aspects of understanding the device and feasibility. That is going to enable us to do the AI for the test program conversion in a more automated and quicker way. The third one going to talk about the SLT. To achieve the complexity of the device we've been produced and the validate the test requirement. One is on the data sheet side and the design side, you can do it. But when it goes to the system level, there are many other factors which defines the device functionality. And to achieve the stringent needs for example, on the mission critical applications like automotive, you need to test the device in the real use case environment. And we have team who understands the OS level of Android or Linux or iOS. So we can write the real test use cases for a device and enable that to bring it to volume. And we also trying to look at, the test times of the SLT is usually in terms of minutes. How do we address the cost of test, moving some of the ATE test, especially the structural test, into the SLT so that SLT has the volume of testing multiple devices in parallel, like in 300s. How do we move some of these structural tests into? So there is a in-house program. We are addressing the solution like implementing 1149.10. The last one is, as I told, the complex device the customer designs. They want a very close interaction with our test team. So we have enabled regional labs. The recent one is the San Jose and Austin that equips different ATE and handler and wafer probers suited for that need. And Bangalore, Singapore, and Penang are the most established ones. So I thought I'll give this update so that it is useful for our customers. Thanks.
Thank you very much, Regan. Next slide.